Hey guys, good morning. So today we'll be discussing a very interesting Windows artifact called Prefetch. So this is a Prefetch101, and by the end of this course you will have this as additional arsenal investigating Windows execution. Okay, let's start. So what is Prefetch? It's actually a mechanism used by Windows to speed up the loading of executable by caching it in a memory. So in effect, speeding up the execution of the executable the next time. So it started on Windows Vista, down to Windows XP, and to the latest versions of Windows 10. And we have Windows 11 right now as well, but I haven't explored that really. So take note guys, this is enabled by default on Windows workstations, OSs like the one I mentioned earlier, Windows 7, Windows 8, Windows 10, but not enabled by default on Windows Server OS versions. So the use of this prefetch is that you can really see the frequently running executables on your machine. But take note, when you open this on a notepad, just like the one I did here on the Notepad++, this is really encrypted in hash format, depending on the OS version. So later we'll dig deeper and I'll show you the parsed contents of this prefetch file, sbcos.exe, or we'll pick another example later. So okay, so what's the characteristic of the prefetch? So mainly, the first characteristic is this is located on the C directory, root directory, then on the Windows, and then on the prefetch directory. And you'll notice here, the file naming convention is that it uses the executable name itself, like this one, svchost.exe dash hash. The hash value of this is the combination of the command line and the executable path. So this varies per OS version because Windows is changing their algorithm as they iterate their OS version. Okay, so the behavior of this prefetch folder is that on the previous versions of OS like Windows XP to Windows 7, this folder will rotate when the prefetch files reach 128 entries. So it can really store up to 128 entries only for the old version. But for Windows 8 up to Windows 10, this can contain up to 1024 prefetch files before deleting the oldest one. So take note, 1024 entries. So that's a lot really. Okay. So next, I'll show you. So this is the encrypted content, but to really parse it, I'll teach you more about it on the next videos. But for here, I already parsed it, so we can focus more on the content. So for example, this one, chrome.exe executable. So here we have the executable name. So this one, you know it, the Chrome browser, and then the hash of the executable plus the command line used to launch at Chrome. I'll actually look for this Chrome. A5. Okay, let's take for example this one, the Chrome. See here the prefetch file of the chrome.exe dash the hash of the command line plus the executable. So when we parse it using a prefetch parser, which I will teach in the next video, see here contents. First we have the executable name, and then the hash of the command line plus the path, and then the file size of the prefetch file, and then the version of the OS where the executable was run. And here we have the run count. So for this one, it has run 77 times on this machine, on this virtual machine I'm showing here. And then the last run was on December 24. This is military time, 7:54 a.m. And then you can also trace the other run times up to the 8 previous run count. So it's very useful when you are building a timeline of an investigation. And then we have here the volume information, including the serial number and the created time, and the summary of the directory's reference and the file's reference. So the directory's reference, these are the directories used by that executable when it runs. So as you can see here, it also contains the actual executable path of the Chrome application. So here. So the red ones are just the color coding used by the parser I am using. It's actually color coding the directories containing temp because those are suspicious really. So but as we know, it's also being frequently used by Microsoft for cache files. And the yellow one is the actual executable path. So here we have the file's reference equals 142. And the yellow one, as I mentioned, is the actual executable path and executable, which is the chrome.exe. And here you can notice there's a lot of DLLs. So if you are studying reverse engineering of malware, you will notice that you can really correlate this with the imported DLLs. Sorry. Okay, let's go back. So that's a lot. In order to really successfully execute this Chrome, it will load all of this. So I'll be creating a video on malware analysis as well. So I'll reference back here so you could really correlate on your own. Okay. So and then what's really the value of this? So it's besides speeding up the execution by caching, it's really a valuable forensic artifact because it lets us know what are the commonly executed or recently executed binaries on our machine. Not only when it was last run, but it shows us the last 9 run times, as you can see here. Show us the last 9 run times. And it also shows us what was run along the executable with the executable, including their complete execution path for further tracing. Then, as I mentioned earlier, if you're studying malware analysis, you can really even trace what are the imported DLLs used by that executable. It will begin to make more sense to you. And then, as I mentioned earlier, this is enabled by default on Windows Workstation. But on servers, you have to enable or change a specific registry key to enable the prefetching behavior. So where is that registry key? I'll show you here. It's actually located on local HKey local machine, then system, current control set, control, session manager, and then memory management. And it's in the Prefetch parameters. Under Prefetch parameters, you have the enable prefetcher value. So since this is a Windows 10 virtual machine, this is enabled by default and has a value of 3. So that's the default value for Workstation Windows OS. So for servers, this is 0 by default. So you have to change it to value of 3 to enable the prefetching behavior. And of course, like any registry change, you have to reboot the machine for it to take effect. Okay, so tune in for my next video to show you how to parse the prefetch. So have a nice day, guys. See you.